Dan. Dan has been very grateful in joining us. I don't want to say as an outsider, but as someone who we tapped, and Debbie and I had a discussion with him and his one of his lieutenants about open source software in general. And so we're very grateful for Dan's time here. So Dan, I think we're going to get started by just asking you to say a little bit about your current role and how you came to fill it. Let you introduce yourself.
Okay, yeah, thanks. So I guess just a brief version of things is as an undergraduate, I became interested in a particular area of computational science because I took a course and then had an advisor that asked me to do a project. And as I continued to work with him for a graduate degree, and then moved into a company and then a national lab, I became interested in more different types of computational science over time, and then data science, and then a bunch of other things. And at some point, I realized that the thing that I actually really liked about all of these things was the software part and not the science part itself. Not that I didn't like the science part, but I like to focus on the software part, and as opposed to thinking of the new science questions, at least at that time. And so that made me interested in kind of how does software get used in research, and how do people work on it, and how do we support people? How do they get credit? How do we understand how software is used in particular discoveries, or how is software used in other software? Um, and and at some point when I was working at the University of Chicago, a colleague of mine who was at NSF asked me if I was interested in going to NSF as a program officer and working there in funding research software. And so I went there for 4 years, where I co-led initially and then led a program called, at that point it was called SI2, it's now called CSSI. CSSI is Cyber Infrastructure for Sustained Scientific Innovation, and it has a fairly strong software piece. And so basically there, the goal was to support researchers who wanted to develop software that would be used by other people to support their research and research that was of interest to NSF. Kind of a quick version of that is that NSF supports lots of different kinds of research, and in those grants, people can build software. And what we were trying to do was to make it so that everybody didn't have to build their own software, but we could give a few people funding to build software that would be useful for lots of researchers, and basically try to invest wisely with taxpayer money. Um, when I left NSF after 4 years, I came here to University of Illinois, and I've been here now for about 9 years. I came as the assistant director for scientific software and applications, and this included a group of about 15 research software engineers. That title wasn't known to everybody here at that time, but we started using that title, which had come up in a UK context and was starting to become known in some parts of the world. Um, I guess we can talk about that a little bit later as well. Um, my current position here at NCSA is that I'm the chief scientist, so I'm doing less hands-on work, and the person that Matt mentioned as my lieutenant was Kenton McHenry, who was the deputy of the scientific software and applications area when I started. And when we went through a little bit of reorganization at NCSA, probably 4 or 5 years ago at this point, Kenton became the director of software for NCSA at the time that I became the chief scientist. And so Kenton's division at this point has about 50 research software engineers now. And so those people are all working on building software for research. There's kind of two different models. One of them is that researchers at the university or outside the university come to us and they say, we need some software in order to do this, or we've built some software in order to do this, but we think it needs some improvement in some way, or it needs some professionalization in some way, and we don't really have good software engineering experience. We're scientists, we're not computer scientists, and so can you work with us on this? And so that's about I would say I don't know, one of the two models of what the group members do. The other model is that when people come to the group and they say they're looking for software to do this, or they want to work on software that does something, Sometimes we see multiple groups that are really kind of doing something very similar, and we realize that we could build some software that would help a lot of different groups. And so when that happens, we start a project. We apply for funding with those researchers as collaborators, where we're going to build some software for them. And part of our goal then is going to be to find other collaborators outside, other users of that software, other contributors over time, and build that up to be a community software package. So I think that's, I don't know, I guess that's a kind of a brief introduction. Hopefully that's okay, Matt.
Yeah, that was wonderful. Thanks a lot. And I think to everybody in chat, hopefully that's like triggering a lot of different kind of questions that might be raised there. Um, so do feel free, chat, to ask questions. Just to clarify, the one of the acronyms that you dropped is the NCSA. That's the National Center for Supercomputing Architecture.
Applications?
Applications, sorry. Yep, applications. And that's here at Illinois. Um,
Yeah, I'll just, sorry, if nobody has questions, I'll just keep talking because
Go
I'm,
for it, and I'll jump in at some point. Keep going, Dan.
no, I really won't do that.
No,
But
yeah,
I'll say that NCSA started about almost 40 years ago when Larry Smarr, who was a professor here at Illinois, wrote an unsolicited proposal to NSF saying that high performance computing and supercomputing was getting to be an important thing for some areas of research, but NSF wasn't supporting it. And he pitched that NSF should support some centers to do this. And NSF eventually agreed, and starting in 1986, there were 5 centers funded nationally, of which we, NCSA, were one of those 5.
neat. So, Dan, you alluded to a little bit of the context over, I think you mentioned in Europe, about the environment that came around, sort of solidifying this concept of an RSE or a research software engineer. Can you say a little bit about, was this a grassroots thing? Was it completely an academic thing, or were there any kind of inputs from industry or the private sector or other scientific boards? How did this, roughly when and how did that concept sort of solidify so that it becomes presentable, or, so that we can organize structures around it?
Yeah. I'll answer that, but first I'll just mention that US RSE, which there's a link to in the chat, is the US Organization for Research Software Engineers. It started with a bunch of us around 2018 and kind of became public in 2019. There are currently a little over 3,000 members, and membership is free. It's just sign up. You can join the Slack and get involved in discussions, and then you can do other things as you want to. Of the members, my guess is that it's about 75% academic, about 15% national lab, and about 5 to 10% industry. And kind of in that national lab category is also other government labs that maybe are not officially national labs, but are government researchers. Yeah, so then to go back to the beginning of all this, in 2012, well, before 2012, there was a group, a project in the UK called the Software Sustainability Institute. It started shortly before 2012. I actually don't know exactly when it started. And it was aimed at trying to make the software that was involved in research better sustained. And so the challenge, which probably a bunch of people, maybe everybody here knows, is that when you build software, it's not done, right? You have to keep working on it over time. The dependencies change, the architecture has changed, people find bugs, people wanted to do more stuff. And so there's a need to keep working on it, and that is often referred to as software sustainability. It's a little bit confusing because when people hear sustainability, they often think environmental sustainability, but this idea of software sustainability is different from that. It's basically just how do we keep the software going over time so that it keeps doing what it needs to do. So that Software Sustainability Institute had been created, and it was running meetings every spring that were kind of informal meetings of, I don't know, 30, 50 people that would come together and would work kind of in an unconference-like sense. So they would decide a bunch of different things they wanted to work on, and then in smaller groups, they would start working on those things. And so in 2012, that meeting that happened in Oxford, I believe, included a group that was working on career paths for people that were working on research software. And there were, I think, about 10 to 12 people that got together in a room, and they were thinking about this and talking about this. And they realized a few different things. They realized that there were a lot of different people that were working on research software in the UK, um, but they had a huge number of titles. And they did a little exercise looking at some data that had been assembled, and found, I think, that there were 154 different titles for people that were all kind of doing similar jobs related to research software. And so they thought about it, and they said, well, we need a title, because if we don't have a common name, people won't take us seriously, and we won't really think of ourselves as unified. And so they came up with research software engineer as the title that they agreed to. And they didn't do this because it was necessarily like the best title they could have come up with. There are some problems with it. There's an issue with using the term engineer in some countries, where engineers have to be professional engineers, and so that title doesn't actually work everywhere. Um, but that was what they agreed with to go forward with, and nobody has really wanted to change it since then. They also realized that they didn't really have an opportunity to talk to each other, and so they decided they would create an association. And so there was a UK Research Software Engineer Association, a Research Software Engineering Association, I think, that was created around that time in 2013. They also started creating groups in some universities, and so University College London, I believe, was the first group, where they brought together a few different people and created a central group and got the university administration to support it. Um, and so then they basically continued meeting for a while, informally, often, at these collaborations workshops that the Software Sustainability Institute created, would help them run every spring. And starting in 2016, they started a RSE conference. So that's been going on annually since 2016 in the UK. Around that same time, I don't remember if it was exactly that same year or a year or two later, they changed the association, which of research software engineering, which was an informal organization, into an official society, which is the equivalent of a 501(c)(3) in the US, but it's called a charitable society in the UK. So that's the Society of Research Software Engineers. That's also, there's a link to there in the notes, in the chat. So their organization is a membership, has a membership fee. I think it's £20 a year, if I remember right. That they have about 700 or 750 dues-paying members, and then their community has another roughly 6,000 people that are on their Slack and chat. And when we were starting this in the US, there were about I would guess maybe 10 people from the US that went to that first meeting in the UK, that first conference. And, and we saw that, and we wanted to create a US organization, and there were people from other countries as well. So there was a Netherlands organization that was formed, and a German organization that was formed, and a Scandinavian, Nordic countries organization, and a few others. And since then, there also are organizations now in Australia, New Zealand. There's kind of a weird story in France, where there's something that had actually started before the UK organization called Devlog, but it's actually quite similar, but works in French and is not as well connected as it could be. And we're working on that. There's organizations in Belgium, in Switzerland, in Canada, probably a few other places I'm forgetting. There's a little bit of work going on that I wouldn't say is quite at the same level in South Africa and in India, but there are people that are that are interested in trying to bring things to that level.
Very
Um,
neat.
yeah, sorry, so that's probably too much.
No,
So
that was great, Dan. And so I feel like you just recorded a history that needs to be shared, and uh, we'll talk about whether or not you're amenable to sharing this whole conversation later on. Um, I wanted to come back to a point that you mentioned, that one of the goals was to think about software sustainability, and this raised the question in my mind. Since this is in place, and now you've got over a decade of kind of this idea in place, has anybody started to measure if software is lasting longer, right? Like, so we have this window where we get funded for 4 years, we build a tool, and then in year five, the software just, will not be sustainable. But is anybody taking an active approach of measuring um, how long these software packages that serve scientists are lasting, and are they sustainable? And I guess the second question to that is, what are some signs of a healthy, sustained software software or set of software, or application? What are some signs that suggest that this is sustainable software?
Um, yeah, that's a really tough question. I guess so. One other thing I didn't mention is the Research Software Alliance, and so let me let me mention that as well. Um, because we have all this different work going on, where we have different RSE associations and groups. Those groups have a loose coordination mechanism that's called the International Council of RSE Associations. But there are other groups that also are working on research software, some of which are supporting activity around research software engineering, like the RSE group, some of which are supporting research software more broadly, like the Software Sustainability Institute, some of which are doing research in research software. So there's groups of people that are interested in software engineering and other parts of computer science that are studying research software and as a subcategory of software engineering and a subcategory of software. And so the Research Software Alliance is a way that all those different groups can get together and work together to try to promote research software and its importance overall. Um, and so there are people that are involved in doing things like you're saying. Um, the specific question that you're asking, Matt, I actually I'm not sure that I've got a good answer to that. Um, I think funders believe that this is important because there are funding activities that are happening in lots of countries, and one of the things that RISA does is to have a funders forum where international funders that support research software can get together about every 6 weeks and share experiences and talk about what they can learn from each other and what they're doing, and in some cases even collaborate. The funding organizations are government funders in many cases. They're philanthropic funders in other cases, like the Chan Zuckerberg Initiative and the Sloan Foundation in the US, as well as a bunch of others. And in some cases, they're industry as well. So just as an example, Oracle has been funding some software development. Google has funded some software development, so there also is industry that's involved in this. But I don't actually know of a particular study that's looking at exactly what you asked at.
Okay, that's good to know. So maybe stepping back a little bit to think about, if people here are thinking about, am I a research software engineer? I think, in our initial conversation at the triptych there, you you and Kenton both laughed and said, "Hey, you guys are research software engineers, right?" We didn't really think of ourselves as that, but I think in reality, we a number of us here at the Species File Group are really filling in that role. So, what sort of skill sets do research software engineers have that um, differentiate them from just software engineers in general? So you mentioned,
Yeah.
I think, in that conversation that research software engineers don't build like payroll type software, for example, or kind of administrative management level software. So can you say a little bit about what differentiates that? Yeah.
Yeah, so I'm happy to, but maybe I'll say, just kind of going back to the beginning of your question, and I kind of mentioned this but didn't really say it in any detail, that there's that at least I see kind of two different concepts, one being research software engineers and the other being research software engineering. And so in my opinion, there's an awful lot of people that do some research software engineering, right? It's basically anybody that is trying to make research software in a reasonably professional way. And so that could include students, it could include postdocs, could include lots of staff members, could include faculty, could include people who think of their title as chemist or some other kind of scientific category. could include librarians. So there's a bunch of different people that can be doing research software engineering. And the way that I think of the distinction of research software engineers is it's somebody who does that for more than half of their time. And it's somebody ideally who is um, evaluated based on the software they produce rather than the papers they produce or the data sets they produce or something else. But there's a lot of overlap, right? And so there's lots of people that are doing research software engineering. Some of them are research software engineers. In terms of the skill part of it, I think it's worth thinking about. Well, I tend to think about this as like a little two-dimensional space that has two axes, and one of these axes is research, and the other one is software engineering. And so you can imagine that there's people that are like really great at research and have almost no software engineering skills. They may write some software, but they don't really have any idea what best practices are, and they're just doing whatever works, and they're not necessarily thinking about is it going to be maintainable over time or is it tested or anything else. And so that's kind of on one side of that. And then on the other side are software engineers on the other axis. And so that's people that have a software engineering degree potentially that have gone through a lot of software engineering training that understand lots of different ideas. Again, testing, test-driven development, Scrum methodologies, Agile, requirements engineering, lots of different things. There's a guide called the SWEBOK, SWEBOK. That's the Software Engineering Book of Knowledge. That a new version 4 just came out earlier this year, and that's in some sense the professional manual of software engineers. Right, so that's kind of the other axis. And so research software engineers and research software engineering is kind of fitting in the middle of those two things. It's not really strong in either one, but it's pretty good in both. So if you take software engineers coming out of computer science, for example, or coming out of industry, they often have really little or no understanding of how research works. They may come to a project if they're brought into a project, and they may say like, well, what are the requirements for this project? Please write them down so that I can build the software for you. Right. I mean that's kind of an extreme example. There's lots of people that are much more collaborative and are not really hands off. But I think this idea of wanting firm requirements ahead of time is one thing that's often typical of software engineering, but often is not something that you can easily do in research. Right. And in research, you don't
Yeah.
necessarily know what the answer is ahead of time. You don't necessarily know kind of what you're going to be doing. You're going to be working with a lot of different people, some of whom maybe want to work on software hands-on, some of whom maybe want to develop software.
Yeah.
Um, there's lots of different ways that you can do this. I guess another thing is that research software engineers typically are not working on one project full time. They're typically working on a few different projects in a few different areas. And their skills are on the software side, but not necessarily on a discipline side. So there's a lot of kind of liaison activity and a lot of translation activity as well. And the carpentries that Debbie mentioned, I think is certainly one of the basic things. Software carpentry is kind of these basic set of skills for people that want to work on software are great. And then there's a bunch of different organizations that build on those skills for more research software engineer skills. Um, so you can think of the carpentry skills as good skills for software, but if you're actually building software projects or software products, then there's kind of another layer of skills on top of that. So just
Yeah.
as an example, I think the carpentries does not currently have any testing module. It's been talked about in the past, but I don't think it's ever quite made it in the curriculum.
Yeah.
But the key thing if you're actually building software that other people are going to use, for example.
Yeah. We talked a little bit about testing yesterday, exactly in this context, and talking about some of the other software efforts that are going on here at the survey. And I was bringing up the concept that how valuable those unit test frameworks are for us in our software development, being able to develop a piece of code, write the specifications, and then come back to it literally like a decade later, see that something has gone wrong because code, as you mentioned, keeps evolving. but then having these tests available to say, hey, you should be looking here and here and here is just a really critical part of software development in my mind. I think that and understanding the power of Git are like the two biggest first steps for me in that software engineering world.
Yeah,
Maybe
and
go
again,
ahead.
I think there's lots of different pieces. Sorry, just
No,
really
go
quick.
for it. Yeah.
So I think yeah, the question about right, Git testing. There's a bunch of different things like that. I think one of the other key things is yeah, and sorry, and Rich, yes, so this is the software engineering book of knowledge is the thing we're talking about. Is that sustainability then becomes one of those challenges. So actually thinking about right, how are we going to keep the software going? Are we going to build community around it? Are we going to make it commercial? If we're building community, how are we going to get people to contribute over time? Should we think about having the software join a nonprofit software foundation like NumFocus, for example, or the Eclipse Foundation, where it becomes hosted in a neutral place and we have a kind of formal governance policies and people that get interested in it can see a way that they can become the owner of the project over time.
Have you
Uh,
seen, Dan, can I interrupt you? Have you
yeah.
seen what number of projects that, for example, the NCSA is working on have kind of migrated towards those neutral projects in your past experience? Are you seeing an increase in these kind of projects that are doing that? What's that route look like? Are those relatively mature projects, I would guess, maybe that are looking for a longer term home, or what
Yeah,
kind of projects make it there?
yeah, so it's definitely relatively mature projects. It's a smallish number of projects. So one of the projects that I work on actually as a developer in a co-PI is called Parcel, PARSL, which kind of stands for Parallel Scripting Library, but not exactly, which is a parallelization and workflow library for Python. And we joined NumFocus about a year ago. I wouldn't say, I mean, software foundations are a home in the sense that they're a place that can support a project intellectually and organizationally. They're not going to support a project financially.
Mhm.
So they're not going to answer the problem about how do you get people to work on this? How do you get funds to support people? They're creating an organizational home where it hopefully is easier to do some of those things and people are more willing to do them.
Okay, yeah, thanks. Debbie, you have a question, and then we'll go to Yuta afterwards.
So the question is more, it's a going back to the carpentries and the bridge. I like the way you described that, Dan. I would say I know in the background, for example, relative to the conversation coming up with AI later after this session, is the carpentries, for example, are talking at this level of what do we teach people about AI and how to use it responsibly and how to document the use of what they're using. And so in the level of the carpentries, trying to ensure that while we're swimming in the lake at the time that the lake is sloshing around and we're all trying to figure out what direction we want to go in, there's a huge conversation going on in the background about what to do, what to teach, what to espouse at the level of the carpentries, right? The introductory level. So,
Yeah.
but a lot of the people at your level, at Matt's level, and others here are having that sort of conversation about how do we navigate that space ourselves. So it's very interesting time.
Right. And there are, again, there are a lot of different projects that are working in this. I'll just say, so Intersect is one in the US. Um, let's see, sorry, it's hard to, um, hard to uh, work on different things at the same time. But there's an RSE summer school that is aimed at students that have gone through software carpentry and doing new things. There's something called um, sorry, I'm missing the name of it. There's a Norwegian project, sorry, a Nordic project that's working in this space as well. There's a UK one. So anyhow, so I guess the thing that I was going to say is that there's really at least 5 different projects that are kind of doing this training at a level above software carpentry, and they all talk to each other and share ideas and share concepts. But they're kind of working in slightly different places, often physically. Code Refinery, sorry, is the Nordic one that I was thinking of.
Very neat. I'm going to read out Yuta's question just so that it's recorded for posterity here. Um, the question, open software is often developed across country boundaries and thus national funding streams. What are the strategies for funding and coordinating development teams that are internationally distributed? How close are we to globally used software being developed by world citizens? And I'll say that we are an international software development team here with Species File. Our big core of our group is down in Argentina, and we would love to see it become more global. So your thoughts on that? You posted a link, Dan, already?
Yeah.
Yeah,
Yeah, so the link that I posted is the RISA funders forum again, where
yeah.
fund organizations get together every 6 weeks or so. I will say that the funding organizations that are there are primarily from the countries that see research software as something important and have thought of it at a national level. And so, unfortunately, that's primarily North America, Europe, and Australasia, with Brazil as kind of the one kind of outstanding point in South America, and particularly FAPESP and in the state of Sao Paulo. Um, we recognize that there's lots of great work going on in other countries, and in particular, a bunch of good work in South America that's happening. But the funding organizations, the national funders, aren't necessarily supporting that at an organized level. They're supporting regular research, and there's software that happens in that, but they're not calling out software as something that they're supporting separately. If I'm wrong about that, and there are organizations, funding organizations that you know of, we'd love to get them involved in the discussion in RISA. I guess, Jutta, I see a DE after that, and I'm assuming that's Germany, hopefully. And so I will say that right, that Germany is one of the leading countries in terms of doing this work. In terms of funding activities, DFG is great in this, and they're quite active participants in the funders forum. There also are a number of private foundations in Germany, the Volkswagen Foundation and sorry, there's another one that I'm not going to get the name of right, so I'm not going to say it, but it's the Klaus somebody Foundation. So there is a lot of work going on in different countries. The activities, the funders often talk about how they could collaborate. Um, International funding is extremely challenging. The Chan Zuckerberg Initiative, that's again a US foundation, has been quite successful at funding people in a bunch of different countries because they don't have government requirements on what they fund. Typically, most government funding agencies have restrictions on funding that can go outside of their country. So the NSF, for example, can fund people in the US, but can't fund people in Canada. The Canadian organization that's called the Digital Research Alliance of Canada can do the same thing. Um, the European Commission creates a mechanism then for cross-European funding, and so some of that happens. And that's great. There are some activities that try to fund across countries. The Belmont Forum is an organization that does some cross-country funding, bringing together those national funders and creating a mechanism where they can do joint peer review, and then different countries fund the parts of selected projects in their own country, but collectively then those projects do get funded. When I was at NSF, we funded something that was called the G8 exascale or maybe petascale software project at that point, where we had to have people from at least 3 countries working together to propose a project. So
Yeah.
it's possible to do these things, but it's really, really challenging.
That raises a question, Dan, to follow up on that. What size of, when a team or a piece of software or a system of software uh, considers going to this level of engagement with that kind of organization, how big is that team? How old is that team? Are these, some of that, when you talk about those levels, that's probably hundreds of people getting together to collaborate on physics level software. But can you say a little bit about the distribution of the size of the teams that engage organizations of that nature?
Yeah, so it really varies a lot, and it varies depending on in some sense, what the funding opportunity is. So the Chan Zuckerberg Initiative was funding software projects that were, I think, up to 2 years and maybe around $200,000. So you can't fund a huge number of people with $200,000 over 2 years. But they didn't care where the people were. And so a project that had international participants would have a bunch of different people that would get together, and they would decide what proposal they wanted to put in and who would be the right people. And they were able to basically ignore national boundaries, which is really nice. Typically, it's very hard to do that, and so then it depends on what the funding opportunity is. I was also involved in a US UK computational chemistry project at one point where I think where we were looking for projects that were 3 years and were roughly $1 million in each side. And so again, that kind of specified how many people could be involved in each side based on that funding that was available.
Okay. Dan, I think if I remember right, that you're involved, change the topic a little bit, or have knowledge of some of the journals that are trying to support, thinking of JOS, the publication of open source software. And I'm wondering if there's any interplay between, we often think about, how do we get scientists to adopt new methods or follow better standards and stuff, and going to the journals and having their editors require certain things is one way to sort of get a community to adopt new practices. Is there a relationship between RSE related communities and the journals in the sense of having them require standards, communicate standards, perhaps even going to those journals and looking for software proactively that would benefit from RSE input and ideas and concepts? Can you say a little bit about journals in that context?
Yeah, so this is a kind of a complicated, messy space as well. And I don't know, like on one side, I feel like I've been involved in a bunch of different parts of it, and maybe that's good. On the other side, I feel like I've been involved in a bunch of different parts of it, and maybe that means that none of them actually have been successful, and then I have to keep finding new paths. So I won't, I guess I won't give any judgment there. But one of the things that I did starting in 2015 was an activity that was under an organization called Force 11. And Force 11 stands for Future of Research Communication and E-Scholarship, and it started in 2011. And that group had created in 2014 a set of data citation principles, and then worked with a bunch of publishers to get those principles implemented. And so if you see kind of any publisher that says like publish your data, cite your data, where is your data, things like that, that's coming out of the Force 11 work. In 2015, we started a similar activity called Software Citation Principles. And in 2016, I think, I think 2016, we published a set of software citation principles. And if somebody Googles software citation principles, then they'll find it. Starting in 2017, then we started doing work called, there was a working group called Software Citation Implementation Working Group, or something like that. And there we tried to think about kind of who are the different stakeholders that we need to impact in order to make software cited. And so publishers was clearly one of those. And we had an activity related to publishing on that. We published a paper in 2018 or 2019 with about 17 different publishing organizations, including IEEE, Elsevier, Nature, Science, Taylor Francis, a bunch of different kind of big groups, some disciplinary groups as well, like AGU, and probably some others that I'm not, AAS and astronomy, and some others. And basically there, we wanted to get all those publishers to have representatives that would say, this is important and we're going to work on this. And so I would say, honestly, when you see something about software citation or software requirements and publishing guides, it's almost certainly because of that. But it didn't necessarily go as far as we would have liked it to. And so that happened, and it's made some progress. But working with publishers is hard, and they've got lots of things they want to do, and they're focused on what helps their model, whatever their model is, if it's commercial, if it's not, anything like that. So and a lot of them were focused on data as well, because data had a bunch of government policy mandates around it, and they thought data was the big thing they needed to work on, and software was not as important as data at that point. So that's kind of one side of this.
Yeah.
A second side is that also around this time in 2016, we started, I and a bunch of other people started the Journal of Open Source Software, or JOSS. We did that in order to give people that had been working on software a way of not doing too much work on a paper, but having some way that they would have something in the system that they could then have reviewed and have published and be citable. And so it's kind of it's different than the argument of software citation, which is that software itself should be cited. This was, we like the idea of software being cited, but it's not happening very quickly. So let's do something else in the meantime. Let's give people an opportunity to write short papers and have those be cited. For JOSS, we have a review process that's a review mostly of the software, although also of the paper. And the review process that we have basically comes from the review process that our OpenSci started for our software that they were doing peer review of. And there's another group called PyOpenSci that does review of Python software as well. So we, along with the Journal of Open Research, Software JORS, and then Software X from Elsevier, have all kind of converged on what are the right criteria to look at in doing software review for publication. And so that's what we do now. So that's, I guess
Yeah,
that's,
thanks. That's a
and,
great cover.
right.
We've
And
got
let me just give you one third part for a second as well,
yeah.
which that in astronomy, the community is quite focused, and there is an astronomy indexing service. There's an astronomy service called ASCL, that's the Astronomy Source Code Library, that takes software and gives it identifiers. The indexing service was called ADS. It's now called SciX, and it's expanding a bit out of astronomy into some other fields. But because there was kind of this nice collaboration of indexers and publishers, AAS that I mentioned before, and an ID service, the astronomy community basically has done much better than other communities, and they've kind of brought all of these things together. So software gets identifiers. When it's used, it gets cited. When those citations are done, they can be counted and people can get credit for them. It's a nice model for, I think, where we have like to bring a lot of these things together, but we haven't quite managed to do that in other
Neat.
fields. Well,
Neat. We've got a question sort of from practically in the chat. I know we have a lot of young, well, I shouldn't say young. I know we have a lot of scientists who dabble in code here. So Fritz is asking, what recommendations would you give for people that don't have a degree in software creation but science degrees and are self-taught in software development to be considered research software engineers? Are there accreditation courses, etc., that would be considered useful to guide you in the right direction? I think you've touched on a myriad of resources, so maybe just a quick 1-2 punch on that front, Dan.
Yeah. So I think, right, so software carpentry is clearly the first piece, but if you're self-taught, you probably know some of what software carpentry will teach already, but there probably are gaps that maybe you don't have as well. And so I think like going through software carpentry is a great way of doing this. Those courses are taught fairly frequently and fairly broadly. And software carpentry has this nice model that I think, I don't actually know where this came from, but I associate it with them now of train the trainers, where after you've gone through software carpentry training, if you actually want to become a software carpentry instructor, there's a course that they'll give you to do that. And then you can become a trainer and give courses in your community or at your institution, or occasionally you'll get people that'll say, we're looking for somebody to do training at, I don't know, University of Hawaii, and we'll pay for your time. Would you like to come and do that? And then people will go and do that. So it's for people that want to get involved in the field, it's a nice way to do that. If you've gone through software carpentry and you feel like you've learned all that, then there's these kind of second level pieces that happen. And again, Intersect in the US, there's something called HPC Universe in the UK, Code Refinery, the RSE summer schools, which are to some extent focused on younger researchers, graduate students and postdocs and early career staff who want to bring code and actually work on that code as part of their training. So there's a kind of a set of these things.
Neat.
Yeah, maybe that.
Thanks. Yeah. So we have another question from Wayne Madison. Wayne is going to be one of our guest panelists, and we're going to ask some of the questions tomorrow. But Wayne is responsible for sort of a legendary set of software tool called Mesquite in our community. If you've done any phylogenetics or taxonomy, you are aware of this tool, and is essentially asking about what simple steps can be done to prep or sort of pre-adapt that software for what is in essence their team's retirement. And I think it's a good question. It's a remarkable set of software, and it's exemplary of I think other successful software that we could identify in our sort of domain of biology. And I guess the question is, if you're gonna package it up and head to the beach, so to speak, what are the couple basic steps to do to give it a fighting chance in the long run? And you'll see a little bit more about what he's describing there in the chat. Yeah, Dan. Yeah.
So first, maybe just because of the archaeologist comment, I'll just mention, which I haven't mentioned before, an organization called Software Heritage. And so if anybody's familiar with the Wayback Machine, that's part of the Internet Archive, that basically is like looking at the web and trying to archive it over time. Software Heritage is doing the same thing for open source. And so if something is in GitHub, it's most likely captured in Software Heritage. If it is in Google Code or something that doesn't exist anymore, it's possible that Software Heritage also captured it before that service went away. So there's kind of a large collection of open source from a lot of different resources that are collected in Software Heritage that lets people then kind of browse them and study them and do computer science research or sociology research of who's contributed or other things like that. But to answer Wayne's question directly, yeah, I think his comment, I expect the answer is not easy, is exactly right. This is not something that is easy. And to some extent, I would say that it's going to be hard to do something if you're not willing to put some time into it. And then the question is kind of how much time. One thing that you can do potentially is to try to work with an RSE organization. And so maybe there are other people that would be interested in getting involved in the software aspects of your project of Mesquite, and maybe helping build community around it or doing something else. If you can find the right collaborator that's interested in the software, then maybe that lets you kind of keep working on the beetles and spiders, and let somebody else focus on the software. I would say honestly, for something to become sustainable, it either has to have a successor, as in right, there's somebody that you kind of train that's younger, and sorry, I mean younger in a institutional sense, not in a necessarily calendar year sense, but that wants to take over and has some of their career left that they can do that, or you build community. In which case, right, you start by thinking about the fact that there's lots of users, and you want to promote some of those users to become contributors, and then you want to recognize those contributors and promote some of them potentially to become maintainers, and then recognize them, and then promote some of those maintainers maybe to become co-leaders over time. And then if you get to having multiple co-leaders, then you're in a situation where a couple of co-leaders leave and the other ones stay, and everything continues because you have this kind of this pyramid of contributions that's happening, and it can continue. And so
I'd like to, yeah.
so you have to kind of choose one of those and pursue it.
I'd like to pitch that maybe there's another conceptual way to think about it. I think that's kind of the understood way. So there's been some interesting concepts about using AI to bootstrap our understanding about things. And those things are, I've heard this argument being made from everything from species concepts to learning basics of math, where you learn a little bit, you interact with the AI, it guides you in a little step, and you interact with the AI and it guides you in a little step. And I'm wondering, in this case of Mesquite, where large language models do a good job of sort of, well, not good job, but they do it. I shouldn't judge the kind of job, but they do a job where they can intake your code base intake all of your documentation, and they can let you ask questions about that. Could this be used to bootstrap a community of people who will start to maintain that software in a way that we previously haven't discovered or previously haven't had available to us? So it's more of a thought experiment, but I do think that there are opportunities for exploring how to do that. So for example, the art, Dan, you didn't see this yesterday, but the art I included on my slides was done because I knew enough about programming. I asked the reasoning version of ChatGPT to develop a tool that will extract the points from an SVG object. And it was very terrible at first, but I kept asking it to iterate. And then the end product was actually remarkable with very little me having to tune any of the code. And so to me, that suggests that, maybe if I have something Mesquite, it's got modules, it's got a code organization, that I could understand that more quickly than I could in the past with this same sort of approach. Maybe not asking for comment, but just thinking about that as an option there.
Yeah, I mean, so I put in a kind of a negative AI view, which isn't completely negative. Actually, it's got some positive aspects as well. I mean, I don't think there's any harm in trying to use AI to try to do things other than potentially you're going to waste some time if it doesn't work. But
Yeah.
that's with all research, so that's fine.
Yeah, we're going to have a session on that AI. I think it's coming up in minutes here, actually, where we could follow that thread. I did want to wrap up, Dan, with a little bit more personal questions for you. One of them was I noticed that you post a lot of and feel free to plug any resources online that you'd like people to follow. I noticed you're on Mastodon and that you publish a lot of bird pictures and sort of natural history related pictures. What's your interest there? And this community is all very familiar with iNaturalist, but we're curious if there's other tools that you would be using on that sort of natural history front, and sort of what do you get out of that enjoyment and posting of all of your beautiful pictures there on that front?
Yeah, so yeah, it's interesting. So I was sorry, this is like kind of a weird discussion in some sense, but I was on one Mastodon server, and then there was some issues with one of the moderators having some I'll be generous and say neo-Nazi views
Yikes.
that led some people to leave that, and I joined the migration away from that. So I just moved Mastodon servers recently, which was kind of an interesting experience about how portable are these things and how does this model really work, which was kind of fun to go through. But back on the kind of on the natural history side, so I think I've always been interested in photography, probably from, I don't know, the time I was like 10 or something like that. And when COVID started, I was realizing that I kind of wanted to do something that was outdoors and that was kind of away from people. And here in East Central Illinois, we have a lot of lovely forest preserves, and most of them are dramatically underused. And so you can go out and walk around and not see people, which is really nice. But when you're there, you do see, all right, prairie plants and other things and birds and insects and kind of all these things that I realized I didn't really know much about at all. And so I kind of started taking pictures of them just in order to identify them in some cases and understand kind of what I was seeing. And then kind of started chatting with some other people that were also involved with birds, and realized that there were like this huge number of birds that were lived here. Well, I mean, not compared to some other areas of the country, but compared to what I knew. And I think if I don't know, I mean, there were just some very basic things that I had no idea of, like that there were multiple species of red birds that lived here, or that we had bluebirds or yellow birds or other things like how do you not see birds that are all these colors? And somehow, right, I'd gone through a bunch of years and not actually ever noticed them. And then I kind of started looking at like these orioles are building really interesting nests. This is kind of fun to watch. Or here's some goldfinches and I found their nest, and now I can see what they do over time and watch the eggs hatch and then see what happens. So so it just became really interesting to me. And so iNaturalist for me was a way of identifying what I've seen mostly, but then also starting to understand what was common and what wasn't common in a place and at a time, and then also being able to contribute to that. And then I guess eBird is probably the other thing that I don't actually contribute much to, but I do end up using to understand what other people are seeing in other places, and in particular the eBird alerts that you can sign up for that tell you when there's something rare that is in a place that you're interested in has been kind of fun for me as well, just to learn about when there's something that isn't normal but people are seeing it. And at least in one case a couple of weeks ago, I drove out to a subdivision in order to see some western cattle egrets that aren't normally here, so that was
Cool.
kind of
Do you use Merlin, Dan? Do you know this
interesting.
app?
Yeah, I do use Merlin a little bit as well. Yeah, I'm not great at bird calls, and sometimes like identifying things through Merlin has been interesting to see. Like that there's something here that I didn't realize was here, then I can look
Yeah.
for it and try to see if I can find it. So yeah, sometimes yes.
All right. Dan, thanks so much. If you want to plug anything in the chat, your Fossidon, I feel like we could keep talking that you've provided this completely amazing history of what's going on there. I feel like there's other questions, but I feel like you've also provided a great resource and a lot of links for us to sort of digest and move forward. And I think I can say a huge thank you for being here. And hopefully the chat agrees with us that we really value your time and your insights, and giving us this context is just really been great for us. Thank you.
You're welcome. I'm also happy to chat with anybody that wants to email me or chat about any of these things, particularly the software related ones, although sure, the bird ones too.
All right.
And
I know that
and
story warmed a lot of our hearts hearing you talk like that. Yeah.